to True Projects. In this video, we are going to explain about the project that is a novel transfer learning approach for detection of pomegranates growth stages. So before getting into the execution, first let us understand what is the project about. Pomegranates, they are packed with nutrients and also antioxidants that makes them super valuable not just as a fruit but also in products like juices, jams and even in cosmetics. Since they are grown in dry and semi dry regions, farmers have to be really careful about how they manage their crops to get the best yield and quality. And now, here the tricky part is knowing the fruit stage, that is, knowing the pomegranate is in particular growth stage is crucial. Why? Because things like fertilization, pest control, and harvesting all depend on it. If you fertilize it too early or too late, it won't be as effective. Harvesting at the wrong time can affect the taste and also shelf life of the fruit. And here the problem is here the problem is that farmers usually rely on manual observation to figure out these growth stages. That means physically checking the plants, which takes a lot of time, effort, and let's be real, it leaves room for mistakes. Different people might judge the same plant differently, and in large scale farms, monitoring every plant accurately is nearly impossible. And on top of that, these pomegranates are prone to diseases, and different diseases show up at different growth stages. If farmers don't catch these diseases early, that is, these issues early, they can spread fast, damaging a huge portion of the crop. And since traditional methods rely on manual observation, they are always at a risk of human error. Imagine having to inspect thousands of trees by eye. It is exhausting, inconsistent, and just not practical at large scale. So, that's why there is need for an automated system that can do this more accurately and efficiently. If farmers had a tool that could quickly and precisely identify the growth of their crops, they would be able to make better decisions, apply resources at the right time, and reduce losses. Instead of guessing, they'd have reliable data to guide them, leading to healthcare crops, that is, healthier crops and better yield. So, here to overcome with all these issues, this project proposes to use deep learning methods to classify the pomegranate stages. That it may be fruit stage, that is early fruit stage, whether it is at bud, flower, mid growth, or ripe. Instead of farmers manually checking each tree, which is time consuming and prone to mistakes, here we bring an AI to do the job more effectively. So, for that, in this project, we are proposing transfer learning based CRNet model. So, here, CRNet model is used that automatically, it is good at analyzing images. It looks at pomegranate pictures, captures important details like size, shape, and texture, and extracts meaningful features. So, here, convolutional neural network model, it is used for extracting the features and then that features are fed into the random forest model and that random forest model will be classifying the pomegranate that it is at which stage. And here, to make the system more effective, we are integrating advanced image classification techniques such as CNN, k nearest neighbor, k neighbor classifier, that is KNC, Gaussian naive bayes and logistic regression. Each of these models contribute to improving accuracy by analyzing pomegranate growth stages from different perspectives. So here we will be comparing the proposed model with all these models. We are incorporating all this model for classification purpose. For comparison purpose, checking which model performs the best comparing to the proposed one. Here, by automating the detection process, the system eliminates the inconsistencies of manual observation, allowing farmers to allocate resources efficiently. It helps in optimizing fertilization schedules, improving pest control strategies, and ensuring timely harvesting. Ultimately, this leads to better crop yield, reducing losses, and also more sustainable approach to pomegranate cultivation. So here we are proposing CRNet in which we will be extracting features using convolutional neural network and random forest for classification purpose. And that is compared with all these models. And to further improve the performance, here we are introducing an hybrid model that is exception plus NASNet. So we have integrated this exception plus NASNet for extracting the important features. So here, this model along with the traditional model, machine learning model that is voting classifier have been integrated. So exception plus NASNet is for feature extraction purpose and ensemble approach voting classifier is to enhance the prediction accuracy for classifying the pomegranate stage. And also we have introduced the detection module. Here we will be detecting the pomegranate's growth stage using YOLO. We will be localizing that image, I mean pomegranate, and then we will be detecting it is at which stage. For that, we are incorporating YOLO based models. Here we are incorporating different versions of the YOLO, enabling highly efficient of growth stages. This is a real time object detection model. That is, you only look once. And here we have built front end using Flask framework. So here we have developed front end using Flask framework. So we propose developing a front end interface using a Flask framework. This interface will allow users to interact with the model for testing and practical application. To ensure secure access, authentication features will be implemented, making the system reliable for farmers and agricultural professionals. This extension aims to bridge the gap between technology and practical farming, offering an efficient and accurate solution for monitoring pomegranate growth stages. Moving on to the implementation. To implement this project, we have followed the steps mentioned in the flow of work. So here we done classification on and also detection. So for classification, we have followed a set of steps. So these are the steps followed for classification purpose and the other set of steps for detection purpose. So let's see what are the steps followed for classification and detection. So first we have imported all the required libraries for image processing and deep learning. Then comes the exploratory data analysis part. So here we work with the pomegranate's growth stages images. So here we will be understanding how the data is. Then comes image processing part. So here we will be applying data augmentation techniques like rescaling, shear transformation, zooming, flipping, and reshaping. And then comes feature extraction part. So here we have extracted features using CNN by reading, resizing, converting colors, encoding labels, converting data to NumPy array. Then we split the data into training and validation sets. So here we will be using training set to train the model and validation set to evaluate the model. Coming to feature extraction, here we have used CNN and the extension model exception plus NASNet for extracting the important features. Then comes early stopping. So here we prevent overfitting or underfitting during the training. And then and then we define and build the classification model. And then train model is used for training the dataset. So here we train the model with optimized parameters. And we store the best performing model for future classification tasks for classifying the pomegranate growth stages. So this is the classification part. Now moving on to the detection. Similar to classification, here also we load required libraries for object detection. And then comes exploratory data analysis. So here we load and visualize the data. And then we do basic image processing where we convert images to blob format. We define object class index, bounding boxes, and also convert data to NumPy array. Then we extract neural network layers and also the output layers. Then comes other image processing part, that is the additional pre-processing. So here we will be appending the images annotation to the annotation files. We convert images from BGR to RGB and also we create mask, we resize the image. And we apply basic data augmentation where we will be randomizing, where we'll be adding random transformations such as rotation and scaling. And then comes processing the data based on YOLO. So here we process the data using YOLO models. And then comes model training and development. So here we build and train the object detection model. And we save the best performing YOLO version for the future detection. And now coming to the front end. So here we have used Flask framework for developing the front end. And also we have added user authentication where we will be having registration and login. And that data will be stored in SQLite database. And here users they can upload images for classification and also detection and that will be pre-processed at the backend. It will be fed with a train model for detecting and also for classification. And finally outcome will be displayed through the front end of the application. And now coming to the algorithms used. So these are the algorithms used in the project. So here CNN used for feature extraction and random forest for classification. Here all are the individual models. And here we have detection models that is YOLO V5X6, YOLO V5S6, YOLO V8N, and YOLO V9N. So this is the extension part. And now coming to the requirements to implement this project, we need basic requirements which are hardware and software. So coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And now coming to software, we need application of Anaconda, primary language of Python, front-end framework of Flask, backend framework Jupyter Notebook, database SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let us execute. To execute, open the code folder that contains source code files. So let's open the code folder of the project. So these are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? Here in this folder, we have the data set that is used in this project. So these are at different stages. Here in this folder, we have the images of pomegranate where it is at bud stage. So these are the images of bud stage. And here in this folder, we have images of early fruits, that is pomegranate where it is in early fruit stage. And here it is at mid fruit stage. And here is at ripe stage, where it is the final stage. And here all these folders, I mean here also we have that is flowers. So here is the flower stage. Let's get back. So all these images are stored in two separate folders, train and validation. So images which are in train folder are used to train the model and images which are in validation folder are used to evaluate the model. Let's get back. And this dataset folder is used for classification purpose. So here we will be training all the random forest, support vector machine, all the machine learning models here we have mentioned, right? So these are the models used. So these are the models used for classification. So this data set is trained on all those models. And now coming to the detection. So here in YOLO V5, we have the data set. You can observe, right, it is split it into two folders, train and valid. Let's open train folder. Here we have two subfolders, one is images and labels. Let's open images. So here we have images of all the stages of the pomegranate. We have clubbed them here and we will be training YOLO V5 model on this images. So these images are trained on the YOLO V5 model and object locations for these images. So that means just let's take example for this image. So here we will be locating, I mean, we will be detecting these two pomegranates, right? So this location we will be having in the annotation files that is in the labels folder. Let's open this folder. So this label folder have annotation files or the labels for objects in the corresponding images. So here each label file, it corresponds to an image file in the image folder. For example, the first image file, that is the first label file, it corresponds to the first label file. It corresponds to this first image file. Similarly, this second image file, it corresponds to the second label file. Accordingly, for all the images, we have an image folder, that is we have total 1912 images. For that, we will be having object locations in this label file. So here you can observe total we have 1912 annotation files. So these annotation files, they follow the YOLO format. Let's open a file for sample. Here, this line represents a detected object. So this line, it represents a detected object. This is the object class index and it is followed by its bounding box coordinates. This is the x limit, y limit, width and the this is the width and this is the height. Similarly, we will be having all the object locations in all the files. Let's get back. And here, the same images we will be having in YOLO V8 and YOLO V9, but they are annotated differently because each YOLO version, it requires its own specific type of image annotations for training and also for testing the models effectively. Having separate folders helps keeping the dataset organized, ensures that each YOLO version receives the correct annotation it needs to function properly. So images which are in these three folders will be used for detection purpose. So here images which are in YOLO V5 are used to train the YOLO V5 model. Accordingly, YOLO V8 and YOLO V9. So these three folders are used for detection purpose and this for classification purpose. And in the sample folder, we have images that we will be using in the front end for detecting and also for classification. We will be using them as the test cases. And coming to the static folder, this folder consists of files related to CSS, JavaScript, and also Bootstrap files, which are important for the visual appeal. And coming to templates folder, this folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have app.py file. So this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have two notebook files. So here we have two Jupyter notebook files. So these are the Jupyter notebook files which contain the combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And here coming to this Jupyter notebook file, here we will be loading the images for classification purpose and we will be training all the models for classifying the pomegranate stage. And coming to detection, here we will be loading all the images which are in YOLO V5, YOLO V8 and YOLO V9 and we will be training all the YOLO models for detection purpose. And here we have multiple model files. So these are the model files. So these are the model files in which we have the algorithm information stored. And that will be loaded into the project code during runtime of the application. So this is the signup.db file. This file is a database file which is used to store the user information. So this is all about the code folder. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. I'm copying it. Now open Anaconda prompt. So here give the command cd, give the space and paste the copied path. Now click on enter. Here you can observe, right, current directory is changed to the code folders path. Now compile app.py. So give the command python space app.py and now click on enter. So this command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port, unless configured differently. So just wait for a while. File is being compiled. That is app.py file is being compiled. So here the application has hosted the app, I mean Flask framework has hosted the application. This is the local host and this is the port. So now copy this local link provided by the Flask framework and paste it into any web browser. I have copied it. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So we need to get signed up. First, click on sign up and enter all the registration details if you are registering newly. I have already registered, so I will directly sign in. Click on sign in and give your username and the password. Click on sign in. We have signed in successfully and we are redirected to classification page of the project. Here we are doing classification and detection. By default, we are redirected to classification. So first, let's do the classification. Here we can see a choose file button, right? We are supposed to click on that for uploading the images. So let's click on that. Open the sample folder. As we're doing classification, first let's open classification folder. So now let's upload images from the bud folder and let's see whether application will correctly predict it, I mean correctly classify it as bud stage or not. So open it. So now let's upload this image. So this given image, it will be pre-processed at the backend. It will be fed to the train model and then train model will be giving us a prediction. So this is the image that we have uploaded and here we got the prediction that as it is at bud stage. So it is correctly classifying. Now let's check with some more images in this folder itself. So now let's upload this one. So here you can observe, right? So these are the buds. These are the pomegranate buds. And here it has correctly predicted that is at it is at bud stage. So this is the image that we have uploaded. Now let's try with the other stages. Click on choose file, get back, open the early fruit stage. So let's upload this one. And here, this is the one we have uploaded. And here we got the prediction that it is at early fruit stage. So this is the early fruit stage. Let's upload some more from the same folder. So now let's upload this one. So here we got the prediction that it is at early fruit stage. Now let's check with other stage. Get back. So now let's upload this one. And here we got the prediction. So this is the uploaded one. And here it has correctly predicted as it is at flower stage. Let's check with one more of the same stage. So now let's upload this one. Here we got the prediction. So here you can observe, right, there are two flowers of the pomegranate planet and here it is correctly predicting it as flower stage. Now let's check with the other stages. So get back, open the mid fruits. So let's upload this one. And here we got the prediction. So this is the uploaded image and here we got the exact prediction that it is at mid fruit stage. So here application is classifying the image to be as mid stage. Let's upload. So now let us upload this one. And here we got the classification. So that is predicted as mid fruit stage. So this is the image that we have uploaded, and here we got the prediction as mid fruit stage. So now let's check with some other folder. Get back. So this is the last stage of pomegranate. Let's upload this one. So here we got the prediction. This is the uploaded one. And here we got the exact prediction that it is at ripe stage. So this image is at ripe stage. So this pomegranate is at ripe stage. Now let's try with one more. So now let's try with this one. Here we got the prediction. So this is the uploaded one. And here we got the prediction as it is at ripe stage. So this is how you need to do classification here. If you observe, when we have uploaded the image, it is just telling it is at which stage. Now we will be doing detection, and I will tell you the difference what is between classification and detection. I will be telling difference between classification and detection after showing you the samples of detection. So let's upload file. Let's upload images. So open sample folder. Let's upload detection. So now let's upload this image. Click on open and now upload it. So here also image will be pre-processed and then it will be fed to the train model and it will be giving us the detection. Here you can observe. It is localizing the object. Here object is nothing but here it is pomegranate plant, or it may be, pomegranate fruit, bud, or anything. Here you can observe a flower, that is a pomegranate flower is being detected in a white color bounding box. It is drawn, it is detected in a white color bounding box. It has given it as it is at flower stage with a 0.990 probability score. Probability score is nothing but it is the confidence level that how accurate the detection is. So here you can observe there are two flowers detected. So when we were giving image for classification, it was just telling what it is at which stage. So coming to detection, it is localizing that pomegranate and it is drawing a bounding box and it is mentioning, it is detecting that it is at which stage. Now let's upload some more. So let's upload this one. So here you can observe a flower has been detected and a bud is detected. So two buds are detected and one flower is detected. Let's get back. And now let us upload this one. So here you can observe there are 1, 2, 3, 4, 5. Total 5 fruits, that is 5 pomegranate fruits are detected, and that too they are in the mid stage. They are in the, pomegranate fruits are in the mid stage. Now let's upload this one. So here you can observe here is a bud and here there are multiple ripe pomegranate fruits. It is at ripe stage. It is at the last stage. And now let us upload. Let's upload this one. So here you can observe that the pomegranate is at early fruit stage. You can observe there are two pomegranate flowers are detected. Two pomegranate fruits are detected. They are at the early stage. So now let's upload this one. So here you can observe there are two flowers detected and one early fruit has been detected. So these two are at flower stage and this one is at early fruit stage. Let's get back. So here you understood the difference between classification and detection, right? In classification, it will just tell it is at which stage, and coming to detection, it will locate that object. It will identify the object. It will draw a bounding box and tell it is at which stage. So now let's check with the graphs. Click on graph. So here we have graphs. So first we have graphs for classification. So this is the accuracy comparison graph. Here on x-axis we have accuracy score and on y-axis we have all the algorithms that are trained for classification. So here we have precision score, here we have recall score, FN score, specificity, and that's all for classification. So these are the metrics used to evaluate the classification models. Now moving on to the detection, here we have precision confidence curve graph, recall curve graph, F1 confidence curve graph, confusion matrix, precision score, recall score, MAP. So here on x-axis we have MAP score and on y-axis we have all the algorithms that are trained for detection. So mean, average, precision, recall and precision are used to evaluate the detection models. So now click on sign out. In this way, just by giving images to the application, if you want classification, you can choose classification. If you want detection, you can choose detection. So it will be classifying and detecting the pomegranate stage. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.